Next speaker is Francesco Pizzocolo, Project and Transition Manager at TNO, the Netherlands Organization for Applied Scientific Research. Francesco got his master's at the University of Brescia in Italy in 2008 as a civil engineer. And during his career, he developed a broad knowledge about materials behaviors in different fields: energy, pharmaceutical, biomedical, and automotive. So after working as a researcher for 4 years at the Eindhoven University of Technology, in 2013 he moved at TNO as a scientist in the Applied Geoscience Group. And since 2017, he is a project manager in the Material Solutions Department. Francesco is responsible for many projects in the energy sector with focus on materials performance. And in his free time, he is a basketball head coach at national level. That's very impressive as well. So please, Francesco, the floor is yours.
Thank you, Ines, for the introduction. I'm the project manager of the Insyde project, so I'm not really involved in the technical development, but more in the manager, marketing, and the business side. So Insyde is a shortcut for bringing advanced heat batteries in residential heat and electric system close to market through real-life demonstration in different climates. So it was very nice to see the presentation of Carlos, because we are trying to develop similar concept using thermochemical materials. So the whole project start because the EU aims to increase the energy share up to 32% in only 10 years time. But of course, this transition comes with big fluctuation in supply and demand. So it's really important to have a system that can store energy and be delivered when needed. As most of the audience will know that the main use of energy in the household is for heating. So in Europe, it goes up to 64%. But at this moment, on the market, there is no compact and affordable solution to efficiently store and supply heat based on the user demand. So the main objective of our project is to advance this groundbreaking closed-loop heat storage concept to technology readiness level of 7, and then to go through a real-life validation in 3 different European climate zones. And so at the end, we really like to deliver an affordable, so in the range of 8,000 euro, and a compact solution with robust, so will last up to more than 25 years performance. So combining hybrid functionality with compact storage with high efficient heat pump, and then to have a configuration for both heat and electricity system to create new opportunity for grid flexibility. So in our project, we did not start from zero, because we already have a validated full-scale demonstrator, as you see in this picture. So this is a technology that it was developed as a combination of TNO and Eindhoven Technology University. And my colleague, Pim Donkers, that is the technical lead for the Insyde project, has been working from this system for quite a while, because he started for his master thesis when he did his PhD on to develop this system, and he now is 3-4 years as well at TNO. So there are 2 main breakthroughs in our technology. So we are using a very stable thermochemical material, and is a very robust closed-loop reactor system. So this thermochemical material is loss-free. So this means that is very stable when the water is hydrated. So when it's a salt, and when the water is stuck in the crystal, it maintains a very good energy density and no energy lost. So it's stable, has a good power, robust, can last for a long year and many years. Is very environmental friendly, and to be chargeable is enough to have a pretty low temperature. So is a very simple system. So it has only 4K components. So on the top right is the reactor, is where the thermochemical material is stored. And during the project, now we are finalizing the design on a optimized system that is smaller and more efficient. Then below the reactor, there is the heat exchanger, then the ventilator, and on the top left, there is the evaporator and condenser. So how does our system work? So we have a discharge and a charge phase. So in the discharge, so we have the cold air that go through the condenser became to be wet, and then it enters into the reactor, and the reactor gives as an output a warm, dry air. During the charge phase is the other way around. So the battery to be charged needs to have an inlet of warm, dry air, and then go through and became cold, wet air, and then dry air, and so on. So this system is quite robust, is already be tested for several cycles, and is very stable. So what we are combining is three main technologies. So we have a multi-cyclic stable thermochemical material, the salt. Then we have combining with a compact thermochemical heat storage system, and then we interface with the energy management of houses or house complex. So we have household that you see the picture in the middle, that there is the thermochemical material connect to the water boiler for your daily storage, but this can go for shower, heating system, washing machine, etc. So the reactor contain approximately 1 cubic meter of thermochemical material. Your daily storage, it gives you like a water buffer for approximately 2 weeks of the hot water that is needed. And then the local production comes from the solar collector. Then we are working on different use cases. So the house can be connected to a low temperature heat network. So for example, when a centralized production of geothermal heat. So there is an inlet in your house of low temperature that you can use to charge the battery. Or there is a use case in which the heat pump is connecting to your thermochemical storage systems, and the electricity as a centralized production that can come from a solar panel or wind turbines, for example. So we have 3 pilot demonstrations in different climates. So the project started 1 year ago. We had this week our first general assembly, and the new reactor system will go in production around May, June in 2021, and will be some extra tests and optimization that have to be done before, and then we're gonna build several machines that are going to be installed in the spring of 2022 in 3 different locations. So will be 2 houses in Eindhoven, the Netherlands, with temperature ranging from 4 to 22 degrees, and hours of sunlight 2 to 7 hours a day. I'm going to be in a very nice location in the south of France, in Saint-Paul-les-Durance, with temperature ranging from 7 to 25 Celsius, and 5 to 12 hours of sunlight. And the last one is in Poland, in the north of Poland, Gdansk, with temperature ranging between -3 and 18 hours of sunlight, 1 to 8. In the last year and a half of the project is really going to be focused in installing first the machine to the demo sites, and then collect as many data as we can about performance of the reactor, the material, and the energy consumption of the houses. So we will integrate our system with a heat pump solar collector. So the air side of heat pump is combined with solar panels, and then we're going to be a smart integration of the condenser side in the heating system to have, and also to have a direct electrical charging. So what is in development now, we have a selection of concept and that we have to adapt to the demo location. Then we will have to integrate our battery with the existing system, because of course some renovation of the house will be necessary, but we want to have our system as many flexible possible to be easily adaptable to all kind of different houses. Then we will be tested under real end user condition. And then we are developing all the ROE, safety, business case, and life cycle assessment. So this is our work plan. I don't want to spend much time in this. Just want to show you that every part of the system is strongly connected. So the material development, for example, needs to go hand by hand with the reactor development. So we have a strong collaboration between all partners, and so far as a project manager to say that I am extremely happy how the project is developing. So this takes me to who's in the project. So what I found very cool that is we mobilize all the key players for the present and future manufacturing distribution change of the heat battery. So the TUI, the University of Eindhoven, together with Evonik and Caldic, we are working on the industrial material production, material manipulation and optimization. This, for example, involve which is the best dimension of the thermochemical material piece, which is the size, which is the shape, how the air flow inside the system, etc. Then STNO, we are also involved in the material manipulation, but also in the optimization of the system design, because we want to make it a bit smaller what it is now, so it can more easily fit in private houses. And then we also working together with BSOL, Ventilarsec, ENGIE for the network integration. One of our main partners is CEA, but as well they are working with us for the design system, but also they have a very strong role in the network integration and the demonstrator user validation. Eindhoven is simply the city. All of Eindhoven is involved for the demo site. Sint-Truidenbroek is social housing in Eindhoven, and Fasada is the Polish partner that is providing help and a demo site there. Last part of this funnel is a settlement, is a Swiss company that is helping us with the exploitation of the product on the market. And they are already conducting several interviews with end users and the main stakeholder of this kind of system to understand, as Carlo mentioned before, what are the end user needs. Otherwise, it will be difficult to have a success on the market. But not only, so we are working with, for example, with architect and industry, because we really like to know how can we put this kind of system into the house market and in the new house market as well. So in total is 12 partners. We come from 5 different countries. Budget of the system is a bit less than 8 million euro. And project started October last year, and it will run until March 2023, so a little bit more than 4 years. So with this is our website. Please give a look at it. We have also some very nice videos on the website and on YouTube that explain how the system works and what are the potential. One last thing that I like to remark is that the system is there and is working. So we are just want to make it as most efficient as we can, but is there. And we are as well in the process of working with the Volt partner to really create a company to bring this system to the market. If I have a minute, so of course, yes, still 3 years to go into really bring the system to a very high technology readiness level. So what we are, the challenges for now is to optimize the thermochemical performance and to minimize the production cost and the size of the reactor. And then we are working with several partners in the manufacturing industry to understand how we can upscale the production for both the thermochemical material and the machine. I hope I did not talk too fast, and if you have any question, I'll be happy to reply.